Today's lesson is the Unit 7 test review. Let's go ahead and get started. Question number 1 is going to give you a convex polygon, and it's going to ask you to find one of the interior angles. In my question 1, I have a 8-sided polygon. It's very important that you focus on how many sides you have because this is going to be n. So my number of sides is 8, and they should tell you, but you can also count. I'm going to go back to lesson 7.1 and I'm going to use this formula right here, which is going to tell me what these 8 angles inside my polygon sum up to. And of course, n is just my number of sides. So I'm going to do 8 minus 2 times 180. And that's going to tell me how much all the angles add up to. And I get 1,080. Okay, so now I'm going to start, and it doesn't matter which order I start in. I'm just going to start at one of the numbers, and I'm going to add them all up, all the numbers that I see inside my polygon. So 117 plus 156 plus 153 plus 118 plus 140 plus 127 plus 134. And I put those all in my calculator, and I got 945. Now this is what the 7 angles add up to. To find angle X, I'm going to take my sum, 1080, and I'm going to subtract the 945 that I got. When I do that, I get 135. This is my answer for X. All right, question number 2 is going to give you a parallelogram to consider, minus QRST, and it's going to ask me some information about some angles. Remember that opposite angles in your parallelogram are congruent. So I know that angle R is equal to all of angle T, not the part of angle T that's 36, but all of it. I also know that angle Q is equal to angle S. So I already have one of my answers because these two are exactly the same. Okay, so there's one of my answers already. The next thing I have to remember from my parallelograms, from their properties, is that the diagonals create alternate interior angles. That means this part of angle R is the same as this part of angle T. The same is true for the other side as well. So I know, let me grab a different color, that this part of angle R is the same as this part of angle T. And notice right here, they have asked me to find angle QRT, or sorry, QTR. Q to T to R. Oh, okay. So, I know what I'm going to do. I'm going to say my number of sides in my parallelogram is 4, and I'm going to use that same formula from the first one to figure out what the 4 angles add up to. Okay, now this is true for any 4-sided shape, any quadrilateral, so parallelograms, rectangles, rhombuses, squares, trapezoids, kites. They all add up to 360. So I'm going to take my 104 and add my 104, my 2 pink angles, the ones at Q and S, and that gives me 208. I am then going to go ahead and subtract 360 minus 208. That's going to give me what the remaining 2 angles are equal to, 152. Now, they are not both 152 because if I quickly add 152 plus 152 plus 208, I get way over 360. So I have to take this and I have to divide it by 2 to get what R and T are equal to. And that would be 76. So all of R is 76 degrees and all of T is 76 degrees. Well, I know that the one part is 36. So let's subtract the 36 and we get 40 degrees. So angle Q I marked it wrong. Oops, what am I doing? This one is 40 degrees. The last thing I have to remember from my parallelogram is that the opposite sides are congruent. So that means the top and the bottom are equal, the left side and the right side are equal. So to find x, I'm simply going to say 2x equals 6. I'm going to divide by 2, and of course, x equals 3. All right, question number 3 and question number 4 are going to talk about a rectangle. And it says, in the rectangle below, EI equals 3x plus 7, GI equals 6x minus 8, and angle IGF is 31 degrees. All right, so I have to remember a couple of things about my properties of my rectangles. And since they're talking about EI and GI, I'm going to focus on them, EI and GI. They are part of a diagonal. So I'm going to go back and look at my properties of my diagonals, and it says that they bisect each other. That means that this part is equal to this part. I also, as I read through my properties, they say that the diagonals are congruent. So this part and this part are equal because that's true in a rectangle. So all of these parts are equal. I need to find x first, and I'm going to do that by setting EI equal to GI. So 3x plus 7 equals 6x minus 8. And I'm just going to go ahead and solve this equation. And then I'm going to plug my answer back in, and I'm going to find what they're asking me to find. All right, there we go. 7 plus 8 is 15. And if I divide that by 3, I get x equals 5. All right, so they gave me 1, and I've got to figure out, though, but they want me to figure out the whole diagonal. So here's what I'm going to do. To find FH, I'm going to multiply by 2 EI, because 2 of these is going to give me a whole, okay, which gives me the same here. Okay, this is equal to this times itself, because this part is the same as this part. So 2 times EI was 3x plus 7. And x was 5. So I'm going to go ahead and put this into my calculator. 3 times 5 is 15, and I can do 2 times 15 plus 7, and I get 44. All right, the angle. Now it says right here that they gave me IGF is 31. That's in the pink. But they want me to find the purple one, which is IFE. Well, I remember reading that a rectangle has 4 right angles. So I'm going to go ahead and put my right angle here and put my right angle here. These two angles are 90 degrees each. Of course, E and H are as well. I could go ahead and add that for you, but they're not going to help me do this problem. It is not as simple as just they're the same, but they kind of are. This triangle right here, triangle IFG, is an isosceles triangle. I know it's isosceles because these two pieces of the diagonal are equal. Not only does an isosceles triangle have 2 equal sides, it has 2 equal angles, and they are the base angles right underneath the equal sides. So this angle here, let me grab my color, is 31 degrees. The whole angle is 90. So to find that purple one that they want me to find, I'm just going to do 90 minus 31, and that's going to give me my purple angle, which is 59 degrees. All right, you're going to have two of these questions, and I do want to do this one because it is just a little bit different with the angles, and it focuses a little bit differently on the isosceles triangle. So I want to go ahead and do this one as well. So we have our triangle. Notice this time they're talking about BD and they're talking about AC, right? Being these two expressions. The diagonals are equal to each other. So let me grab my color here. I can go ahead and say that BD is equal to AC because my diagonals are congruent. Remember, each of the pieces is congruent and the whole, which means the whole thing is congruent as well. So I'm going to say 4x plus 2 is equal to 5x minus 8. And I'm going to go ahead and solve this equation, and then we'll do some substitution once again. Oh, nice. We got just x plus 8. X is 10. Perfect. Okay, so BD and AC are the whole thing. BC and AC are the whole thing, but they're only asking for this little piece right here. Well, to find to find AE, it's going to be half of of AC. So I'm going to go ahead and plug in 1/2 times AC was 5 times x minus 8. And of course, x was 10. So I'm going to go ahead and put in my calculator 1/2 times 5 times 10, or 50, minus 8. And I get an answer of 21. 21. All right. Now, they gave me angle AED, which is this angle in the pink right here in the center. And then they asked for angle ECB, which is the purple one right here in the corner. Just like in the last triangle, or just like in the last rectangle, I know that this is 90 degrees, and I know that this is 90 degrees. I also know that A and D are 90 degrees as well. I also know that this triangle where the purple one angle is an isosceles triangle, which means this angle here is the same as this angle there. Okay, the other thing that I know is that this angle here at E is also 112 degrees because they are they are vertical angles, right? They share that point right here in the center, so that makes them congruent. Now I have a triangle that I know one of the angles to, and I know that the other two angles are equal. I'm going to use the fact that a triangle is 180 degrees, and I'm going to subtract the angle that I'm given, 112, which gives me 68. In my triangle, I have 68 degrees left, and I have two equal angles, right? I have two equal angles. So all I have to do is take this and divide it by 2, and that's going to give me what my purple angle is, which is 34 degrees. All right, question number 5 is going to ask you, it's going to give you some information, and it's going to ask you to select all the classifications that must be true. Each figure is drawn to look like a rectangle, but that does not necessarily mean that it is one. You have to pay attention to the markings. Okay, and then I'm guessing that that last sentence there, you can click on what the markings on the figure indicate, and it will tell you, and you shouldn't lose any credit for doing that. Okay, so the first one, all of them are going to be quadrilaterals because a quadrilateral just means that we have 4 sides. So if we look at all of them, they all have 4 sides. So I'm going to go ahead and I'm going to mark a quadrilateral for all of them. That's just a given. Okay, quadrilateral just means we have 4 sides. Now, A rectangle, I know that a rectangle has four right angles. So in the last one, I can see that there's a right angle here at C. So this one for sure, oops, this one for sure is a rectangle, which means it is also a parallelogram because a rectangle is a parallelogram and a quadrilateral. So if you click rectangle, you want to click all three. Now, should I click anything else? Well, not only does a rectangle have four right angles, it also means that it has four congruent angles. So that makes the second one also a rectangle, which means it is also a parallelogram. All right, this leaves my first figure, my first quadrilateral. I can't tell anything about the angle, so I really can't tell if it's a rectangle or not. But I do see that the top is equal to the bottom and the left side is equal to the right side. Thus, it is a parallelogram because opposite sides are congruent in a parallelogram. All right, let's take a look at question number 6. Answer the questions about the figures below. So the first one is asking which figures are parallelograms. It is asking you to mark all that apply. Now in my family of parallelograms, I have three members. I have a rectangle, I have a rhombus, and I have a square. So every rectangle is a parallelogram, every rhombus is a parallelogram, and every square is a parallelogram. So looking at these figures, I'm going to say that A, B, and C are all parallelograms. Now, the parallelogram that I have in my mind is, of course, figure C. This is what a parallelogram looks like to me. But the other two are just special types of parallelograms. All right, moving on. Let's take a look at the rectangle. Which figures are rectangles? Which figures are rectangles? Well, I can tell that figure A is a rectangle. It looks like what I have in my brain as a picture of a rectangle. But take a look at figure B. Figure B has four congruent sides. That means this side is equal to this side, and this side is equal to this side. Now, technically, they are all the same, so I should come back and do this, right? Which makes figure B a square. But remember, a square is a special type of rectangle, so I need to also say that figure B is a rectangle. I've already answered question C. The only one that is a square is figure B because it's the only one with the four right angles and the four congruent sides. All right. Question number 7 and question number 8 are going to ask you about a rhombus. Now remember, you might need to use this formula from the beginning of the review to help you find the sum of the interior angles. So my rhombus has four sides, and 4 minus 2 is 2 times 180 is 360. All right. Now I'm going to go ahead and I'm going to look at my properties of rhombuses. I'm going to focus on the angles because that's what they're asking in these pictures. And I'm going to focus on the diagonals because I see them in the picture. So one thing I notice first is that the opposite angles are congruent. So this angle here is equal to this angle here. This angle here is equal to this angle here. As I start to look a little bit closer at my properties of rhombuses, I notice that the diagonals, these lines right here, they split the opposite angles in half. They bisect it. So this part is equal to this part. This part is equal to this part. This part is equal to this part. And this part is equal to this part. So I already know that angle 3 is 42 degrees. I'm going to go ahead and I'm going to add 42 plus 42. which is of course 84. And that means that this angle here in the corner is 84 degrees, as is this angle here in this corner. They're both 84 degrees. I'm now going to use my 360 to help me figure out what those other two angles are, what this angle and this angle are. Remember that they are the same, so you're going to add 84 plus 84, which gives you 168. The whole thing is 360, so you're going to say 360 minus 168, which gives you 192. And you're going to take and you're going to divide that by 2 because remember the diagonal is bisecting it. And that gives me 96 degrees. So this whole angle is 192. This whole angle is 192. But each piece is 96 degrees. So 96, 96, 96. Because 1, 2, and 4 are all equal. Question number 8 is going to do basically the same thing. It's just going to give you different numbers. So I'll go ahead and do it really fast. Just to quick show you. These angles are the same as this angle. That angle is the same as this angle. So I'm going to go ahead and I can already say that angle 4, I already know that angle 4 is 38, and I already know that angle 2 is 38 as well. So angle 2, 38, angle 4, 38. I need to go ahead and add 38 plus 38 because I need to know what those whole angles are at those 2 points. So this one is 76, this one is 76. Remember all 4 of them, 1 plus 2 plus 3 plus 4 equals 360. So I'm going to add 76 plus 76, which gives me 152. And then just like before, I'm going to take my 360, I'm going to subtract my 152, which gives me 208. I need to divide that by 2, I guess the pink, and that's going to give me what angle 1 and 3 are. I don't have to divide by 2 again because it's not splitting it in half. All right, my last 2 questions are going to be answering questions about different properties of my quadrilaterals. So the first question number 9 is going to give you some true or false statements. Be careful when you read a generalized statement that says every blank is a blank. Be careful because it's very generalized. Normally when we say every and fill in the blank is a blank, it's probably not true, okay? So just be careful. There are some instances where it are, like a square is a rectangle and a square is a rhombus. So I can say every square is a rectangle, or I could say every square is a rhombus. But I cannot say every rectangle or every parallelogram is a rectangle. I can't say something like this. So every rectangle is a parallelogram. Every rectangle is a parallelogram. Now that actually is true. That is actually true because a rectangle is a parallelogram. It is both of them. So that one is true. But you wouldn't want to say it in the reverse. Every parallelogram is a rectangle. No, because some of them are rhombuses and some of them are squares. Every quadrilateral is a rhombus. A quadrilateral just means that I have 4 sides. Not every 4-sided figure is a rhombus. We can also have kites and trapezoids and squares and rectangles. So this one is definitely false. Every rhombus is a rectangle. No, every rhombus is a parallelogram. Every rhombus is a quadrilateral, but rhombuses are never going to be rectangles because rhombuses have to have 4 congruent sides and rectangles just don't. Every rectangle with 4 congruent sides is a square. Every rectangle with 4 congruent sides is a square. This is true A square is a special type of rectangle that has four congruent sides. So this is true. All right, and our last question is just going to ask you to select all the properties that must be true. So I have a trapezoid, a rectangle, and a parallelogram, and I just have to read each one of the properties across the top, and if it's true, I'm going to click it. If it's not, I'm going to leave it unclicked. A trapezoid. Four right angles? No. A trapezoid. All congruent sides? No. Two pairs of parallel sides? Not in a trapezoid. A trapezoid has only one pair of parallel sides, so that's the only one I'm going to click for the trapezoid. A rectangle. Four congruent angles? Yes. All sides are congruent? No. Two pairs of parallel sides? Yes, because it is a parallelogram. One pair of parallels? Only one pair of parallel sides? No, it has two, so I'm going to leave that one unclicked. A parallelogram. Four right angles? Not all the time. All sides congruent? No, not all the time. Two pairs of parallel sides? Yes. Only one pair of parallel sides? No. Good luck, guys.